This topic is about sketching graphs of reciprocal functions by considering the asymptotes and the x and y intercepts. Okay, so reciprocal functions are of the form y is equal to k over x, and there are two situations that you need to worry about. The first one being k is greater than 0. Okay, so when k is positive, then your graph looks like this. So there's two parts to the reciprocal graph. The first part is in the first quadrant, and the second part is in the third quadrant. Okay, there are asymptotes, so lines where the graph never reaches, so it's undefined at these points, at these lines. Okay, so there are two asymptotes, one at x equals 0 and one at y equals 0. Okay, so if I were to write down all the features of this graph, then we know that there are no x-intercepts, no x-intercept and y-intercepts. Okay, we know there are two asymptotes, so the asymptotes at x equals 0 and y equals 0. Okay, and the other features that you can write down is what's happening, obviously in more detail. Now you don't have to know this in mathematical language, but I can explain it in mathematical language. As x tends to positive infinity, which means as x gets very, very large, you can see y value is getting closer and closer to 0. So y gets closer and closer to 0, but the 0 is always, the number that is getting closer and closer to is always positive. So it's getting closer to 0, but it's positive always, and positive part of half of the graph. Similarly, as x tends to negative infinity, so at x gets very, very, x gets very, very negative, then you can see y is still getting closer and closer to 0, but the number is always negative, so it's 0 negative, so it's a negative number getting closer and closer to 0. Okay, also as x tends to 0 positive, so as x gets closer and closer to 0 in the positive side, then you can see y gets closer and closer to, gets very big, so it's gets closer and closer to positive infinity. And as x tends to 0 from the negative direction, so here, you can see y is getting more and more negative, so negative infinity. Similarly, if I have y is equal to k over x, where k is less than 0, then if I were to sketch the graph, again we have two parts to this graph, but we have one part in the second quadrant and the second part in the fourth quadrant. Again, the asymptotes remain the same. So these are the lines where the function is undefined. So again, we have the same situation where there are no x-intercepts or y-intercepts. We still have the asymptote at x equals 0 and y equals 0. Let's see how these things change, because obviously they don't look the same, so they are changing. So as x tends to infinity, so as x is getting very, very big, y is tending to 0, so getting closer and closer to 0, but from the negative direction. As x tends to negative infinity, you can see y is still getting closer and closer to 0, but in the positive side. As x tends to 0 from the positive side, so here, you can see y is getting more and more negative, so it's approaching negative infinity. And as x tends to 0 from the negative direction, so here you can see y is tending to positive infinity. So those are the features of the graph. So remember, when k is positive, it's in quadrant 1 and 3, and when k is negative, it's in quadrant 2 and 4. Don't write the 1, 2, 3, 4 in the diagram, obviously, but just for you to remember it. One other thing to note is what happens when we have y is equal to 2 over x and y is equal to 3 over x. If we just sketch those in the same graph, because the 3 is bigger than 2, let's see how it affects the graph. So if I were to draw this one, the blue one, as y is equal to 2 over x, so remember these are sketches, so they don't have to be perfect. So y is equal to 2 over x is the blue one. Then because y is equal to 3 over x, the numerator is bigger. What happens is it's got the y equals 3 over x has the same shape, but it just goes a bit further away from the axis. So it will still be the same shape, but just a bit further out. So y is equal to 3 over x. So as you make k bigger, it'll go further and further out, but the shape, if you zoom out and look at the shape, it's still the same shape. Okay, but in all these scenarios, they're all sketches. So all you have to label when you have these sort of questions is whether it has an x-intercept or y-intercept and any asymptotes. Obviously, the asymptotes are both the same for both equations. That would be it. Okay, you also need to know the graph of y is equal to k over x squared. Okay, so again, you have two different scenarios. So y is equal to k over x squared when k is greater than 0. Now, because again you have k over x squared, this number is always going to be positive, because as soon as you square a number, you have positive, and k is positive, so you're always going to get everything, values are positive. So what you end up with is a graph in the first quadrant and the second quadrant. And the asymptotes are at x equals 0 and y equals 0. So again, if you were to write the features in note form, then there are no x-intercepts or y-intercepts. You have asymptotes at x equals 0 and y equals 0. As x tends to infinity, y tends to 0 in the positive side. As x tends to negative infinity, y tends to again 0 plus. So you can see it's getting closer and closer to 0 on both sides and 0 from the positive side. As x tends to 0 from the positive direction, you can see y is getting closer and closer to infinity. And as x tends to 0 from the negative side, y is also tending to infinity. Okay, in a similar way, if you have y is equal to k over x squared, where k is less than 0, then if you were to sketch it out, because k is negative now, then k over x squared will always be negative, so you end up getting a graph in the third and fourth quadrant. Again, your asymptotes are still the x-axis and the y-axis. So again, in the first one, you had it in quadrant 1 and 2. This one is in quadrant 3 and 4. So if you had to write it, the features in note form, so again, you have no x-intercepts or y-intercepts. Asymptotes at x equals 0 and y equals 0. As x tends to infinity, you can see y is 10 to 0 from the negative direction, because everything's below the x-axis now. As x tends to negative infinity, y is still tending to 0, from the negative part again. As x tends to 0 in the positive part, you can see y is tending to negative infinity, and as x tends to 0 from the negative, y is still tending to negative infinity. So now that we've gone through all the theory, which is here, okay, we're going to answer some questions. So let's go through some questions and examples. Okay, sketch each pair of graphs on one diagram. Okay, so let's answer A first. This is x and y. So 2 over x looks, oops. 2 over x as an asymptote at the x-axis and the y-axis. Let's try that again. So try to make it as smooth as you can. Getting closer and closer to the axis. There you go. So that is y is equal to 2 over x. If I were to label the asymptotes still at, so this one's x equals 0, and that one's y equals 0. Okay, and y is equal to 4 over x. If I were to do that one in a different color, because 4 is bigger than 2, it's going to be the same shape but a bit further out. So somewhere there and somewhere there. Okay, not quite happy with that color, but I'll change it for the next one. Y is equal to 4 over x. Okay, again, the asymptote labels are still the same, so I'm just going to write it there. So that would be it. So and then let's look at the next one. X and y. So now we've got 2 over x and minus 2 over x. So 2 over x is easy. It's the positive reciprocal function. So it's in quadrant 1 and 3. So this is y is equal to 2 over x. If I were to label the asymptote, this is y equals 0. And this is x equals 0. Just to be on the safe side in an exam, always label it. So draw the dashed line and then label it. Okay, if I were to do a different, let's do a different color. Let's do green. Okay, so minus 2 over x is the same graph, but it's in quadrant 2 and 4. So y is equal to negative 2 over x. Again, the asymptotes are the same, so I'm just going to label it x equals 0 and y equals 0. So that would be it. Okay, C now. Y is equal to negative 4 over x. Negative 4 over x is a negative reciprocal graph, so it's going to be here. Because I've got negative 4 over x and negative 2 over x, I'm actually doing negative 2 over x first, yeah. So negative 2 over x is this one. So y is equal to negative 2 over x, because negative 4 over x will be further away from the axis. So that is that. Y equals 0 and x equals 0 are the asymptotes. So if I change it to this one, then negative 4 over x will be the same thing, but a bit further out. So y is equal to negative 4 over x. Again, asymptote at x equals 0 and y equals 0. So that would be it. Okay, next question. Sketch each pair of graphs on one diagram again. Okay, so for this one, A, so we've got k over x squared now. So 2 over x squared, if I were to draw it, is in the first quadrant. and the second quadrant. So again, rough sketch, as long as you label your asymptote and your graph, y is equal to 2 over x squared. This is y equals 0, x equals 0. 5 over x squared would be similar but a bit further away from the axis. So if I were to draw it, it's still the same but a bit further out. Getting closer and closer to 0. So x equals 0 and y equals 0. Y is equal to 5 over x squared. Okay, let's look at the next one. 3 over x squared. 3 over x squared. Again, it's still a k over x squared graph, so quadrant 1 and 2. So y is equal to 3 over x squared. Asymptote at x equals 0 and y equals 0. Negative 3 over x squared will be the negative x squared graph, so it will be quadrant 3 and quadrant 4. So y is equal to negative 3 over x squared, and your asymptotes are still the same. Okay, the last one. Okay, negative 2 over x squared and negative 6 over x squared. So negative 2 over x squared will be quadrant 3 and quadrant 4. X equals 0 and y equals 0 asymptotes for that one. With negative 6 over x squared, will be the same shape, but a bit further out. X equals 0 and y equals 0 for that one. Okay. Let's go to the next question now. On the same axis, sketch the curve given by y is equal to 1 over x and minus x over x minus 1 squared. Okay, so if we were to sketch it out, so the first one is a reciprocal graph, so it's just a plain reciprocal graph. So we've got in the first quadrant and the third quadrant, so y is equal to 1 over x, and your asymptotes are x equals 0 and y equals 0. So y equals 0 and x equals 0. Let's go for green for the next one. So y is equal to negative x times x minus 1 squared is a cubic graph. So cubic graph, so it's a negative cubic graph. So negative cubic graph, so it's going to look this way. It's got a double root at 1. Double root at 1 and single root at x equals 0. Single root at 0, which means it's going to let's try to do this properly. So it's going to cross over at x equals 0, so I'm just going to label it as 0. At 1, it's going to bounce off it because it's double root. Starts off at quadrant 3, and then it's quadrant 2 and ends up at 4. So it's going to look something like this. So 0 is a single root, so it's going to cross over to the other side. At 1, it's going to hit it, and then because it's double root, it's going to bounce off it. Then it's going to go back. Let's just relabel this one as 1. Yep, so that's 1. Okay, that's A done. Part B. Explain how your sketch shows that there are no real solutions to the equation 1 plus x squared times x minus 1 squared is equal to 0. So we're trying to solve 1 plus x squared times x minus 1 squared is equal to 0. It's the same thing as solving 1 is equal to x squared, So if I take the second term to the other side, I get negative x squared times x minus 1 squared. And if I now divide both sides by x, then I get 1 over x is equal to negative x times x minus 1 squared. So solving the first equation, the same thing as solving this last equation. So now if I were to solve it graphically, then we're looking at, if you sketch both sides of the equation, then the number of intersection tells you how many solutions there are. So if you sketch 1 over x and negative x times x minus 1 squared, then the number of intersections is equal to the number of solutions to 1 plus x squared times x minus 1 squared equals 0. So, and as we can see, the graphs do not intersect. Therefore, no real solutions to 1 plus x squared times x minus 1 squared is equal to 0. Okay, next question. On the same axis, sketch the curves given by y is equal to x squared times x plus a and y is equal to b over x, where a and b are both positive constants. Okay, so let's try to sketch this. Okay, so this is a cubic graph. It's a positive cubic graph. Positive cubic, so that means it's going to go this way. Could start off at quadrant 3, end up at 1. Double root at x equals 0, so it's going to bounce off that part, and single root at x equals negative a, which is going to be a negative number. That means this graph will go to negative a and 0. So it starts off at quadrant 3. It's going to cross over at negative a because it's a single root. It's going to come back down and hit x equals 0. Because it's a double root, it's going to go off on the same side. So it's not going to cross over to the other side. So that one's the cubic graph. Okay, b over x, because b is positive, you know that b over x is a positive reciprocal graph. So it will be in the first quadrant and the third quadrant. And best to always label the asymptotes. Y equals 0, x equals 0. Okay, so that's part A done. Part B, using a sketch, state giving a reason the number of real solutions to the equation x to the power 4 plus ax cubed minus b equal to 0. So x to the power 4 plus ax cubed minus b equals 0 is the same thing as solving x to the power 4 plus ax cubed is equal to b, which is the same thing as solving x, dividing both sides by x, so I get x cubed plus ax squared is equal to b over x. If I factorize the left-hand side, I get x squared times x plus a is equal to b over x. So if I sketch y is equal to x squared times x plus a and y is equal to b over x, then the number of intersections is equal to the number of solutions. Therefore, since the number of solutions, since the number of intersections, so let's see how many do we have, is we've got one intersection here and we've got one intersection there, is 2, the number of real solutions is 2. Okay, these are a bit more difficult, but hopefully not too difficult. Okay, so first thing is you sketch y is equal to 1 over x minus 2. Now the first thing you know is the asymptote occurs when denominator equals 0. Okay, which means that when x minus 2 equals 0, this means x at x is equal to 2. So if I were to sketch it here, then if you, at x is equal to 2, somewhere here, we know there's an asymptote. X equals 2. Okay, again, we can find the x-intercept and the y-intercept. So we know we want to get the y-intercept. So x is equal to 0. We know x is equal to 0 at the y-intercept, which means y is equal to 1 over minus 2. Okay, so at y, so y is equal to minus half, which is somewhere here. So if I were to label it, this is the y-intercept. Okay, x-intercept means y is equal to 0, which implies 1 over x minus 2 is equal to 0. Now that we can't solve that, so no solution, therefore no x-intercept. Okay, that's it. There is no x-intercept. That means that the asymptote is at y equals 0. Okay, and now because we know this is a positive reciprocal graph, we can basically know the shape. So it looks something like so, where it's getting closer and closer to x equals 2, but never reaches there, and it must be this way. So it's just like the reciprocal graph shifted slightly to the right. After we look at transformations with graphs, this will make more sense. Okay, let's look at the second example. So here for the second example, we know asymptote when denominator equals 0, which means when x plus 3 equals 0, which means when x is equal to negative 3. Okay, so if I were to sketch it, negative 3 somewhere here. At x equals negative 3, we have an asymptote. Okay, if I do the y-intercept next, x equals 0 implies y is equal to 1 over 3. So 1 over 3 is somewhere here, 1 over 3. X-intercept, so for the x-intercept now, we have y equal to 0, which means 1 over x plus 3 is equal to 0. Again, there is no solution for that, therefore no x-intercept, which means we have an asymptote at y equals 0. Again, if you look at y is equal to 1 over x plus 3, that is a positive reciprocal. So you would end up with something that looks like a positive reciprocal graph, like that. Now let's look at more complicated reciprocal equations. So when you have something like this, sketching y is equal to ax plus b over cx plus d. So let's go through. The first thing you need to know is the y-intercept. So y-intercept. Now at the y-intercept, you know x is equal to 0. So it occurs when x equals 0, which means that ax plus b over cx plus d is equal to b over d. Therefore, 0b over d is the y-intercept. Okay. Similarly, if you have x-intercept, let's see what we get for the x-intercept. This occurs when y is equal to 0, which implies that ax plus b over cx plus d is equal to 0. But that only means that the numerator is equal to 0. So ax plus b is equal to 0, which implies x is equal to minus b over a. So therefore, minus b over a, 0, is the x-intercept. So I'm just going to highlight what we get as the x-intercept. So the key points of this exercise. Okay, now the vertical asymptote. So remember, we always get two asymptotes, the vertical asymptote and the horizontal asymptote. This occurs when denominator equals 0, which implies cx plus d is equal to 0, which implies x is equal to minus d over c is a vertical asymptote. Okay, next one is the last one that we need to know, which is the hardest one, is the horizontal asymptote. So this occurs when x gets closer and closer to positive and negative infinity. So what happens when x gets closer and closer, so a very big positive number or a very big negative number? Then limit as x tends to positive or negative infinity of ax plus b over cx plus d. We know that b and d, because b and d are very small numbers, they're not going to be big numbers, they're insignificant. So what happens is that this number gets closer and closer to ax over cx, because b and d are insignificant, because x has become so large that b and d are nothing in comparison, so it's insignificant. So all we're left with is ax over cx. Let me just write the cx clearly, because otherwise you're going to get confused. And ax over cx is just a over c. Therefore, y is equal to a over c is the horizontal asymptote. So that's the last key knowledge that you need to know when you're sketching these ones. Okay, so the best thing to do is to go through an example. So let's go through an example. Okay, so first thing I need to do is the y-intercept, which means x equals 0 implies that we get y is equal to minus 1 over 5. So if I were to sketch this, So y is equal to minus 1 over 5 is my y-intercept. Okay, next is the x-intercept, which means y is equal to 0, which implies 3x minus 1 over 2x plus 5 is equal to 0, which only means that 3x minus 1 is equal to 0, which means x must be equal to a third. So x is equal to a third is the x-intercept. Next one is the vertical. The vertical asymptote is when the denominator is equal to 0. So denominator equals 0, which implies 2x plus 5 is equal to 0, which implies x is equal to minus 5 over 2, which is minus 2.5. So x is equal to minus 5 over 2 is the vertical asymptote. The last one, which is the horizontal asymptote, is when x gets very large, positive or negative. So 3x minus 1 over 2x plus 5. So these constants are insignificant, so it becomes 3x over 2x, which is just 3 over 2. So y is equal to 3 over 2. So 3 over 2 somewhere here. Y is equal to 3 over 2 is my horizontal asymptote. So now looking at this, I can clearly see my graph will look something like so. And the other part of my graph will be in this part of the graph. So that would be it. Let's look at the next example. So if you're looking at this example, again, I need to first work out the y-intercept, which happens when x equals 0, which implies y is equal to 6 over negative 5. So if I were to sketch it out, so y is equal to negative 6 over 5 is my y-intercept. X-intercept is when y equals 0, which implies 2x plus 6 must be equal to 0, because the numerator has to be equal to 0, which means x is equal to negative 6 over 2, which is negative 3. Negative 3, so negative 3 is here, which is the x-intercept. Next thing I need to do is the vertical asymptote, which is when denominator equals 0, which means x minus 5 equals 0, which implies x is equal to 5. And so at x equals to 5, we have a vertical asymptote. If we have the horizontal, look at the horizontal asymptote now. So remember what happened when limit x tends to positive and negative infinity of 2x plus 6 over x minus 5. This gets closer and closer to 2x over x, which is equal to just 2. So that means x, so y equal to, so y is equal to 2 somewhere here. Y is equal to 2 is an asymptote as well. So now you can see, I just extend this line. That means it's going to go through these points. So that's my first section of the graph, which means the opposite side must have my second section of the graph. That would be it. And don't worry too much about the shape as long as the x-intercept, y-intercept, and the asymptotes are labeled correctly.